All right. Sorry, I took a few moments to go around and I'm still learning your names. I always like to do that, so hopefully within a week I'll know all of you. Uh, okay, so if I stop in the middle of a lecture, I tend to have a recap questions. Don't look back at your notes. Just let's have a discussion together and try to remember what we talked about last time so that we can catch up and continue the lecture. So we talked about why do we analyze food, and there are perspectives from a consumer concern perspective, from the industry, and then from the government. We haven't gotten to the government part yet, but we talked about consumer perspective. So from a consumer perspective, let's try to recall, why do we analyze food? Claire? Safety. That's a good one. Claire? There's one Claire. I thought there was one Claire. And you say your name out. Yeah. So safety, quality, Caitlin? Consistency. Ali, what did you want to say? Yes, care for health and nutrition. Sam, did you want to say anything else? I think that was pretty it. So consumers care for their health and nutrition, for safety obviously, for consistent and acceptable quality. So that's good. Why do we analyze food from an industry perspective? Grace? Competition, exactly. So that's the reason we want to analyze food. Well, you're going to do reverse engineering next week, so that's the first thing that they would do to understand what the formulation of the competitive product is, plus analyzing composition and other things. What else? Let's go with, Luna. Oh, Luna doesn't go, but her, you got her? Okay. Revenue, to change cost, to reduce cost, changing, let's say we talked about butter, changing it to vegetable fat. So yes, reduction of cost and how that would impact quality and safety and shelf life and all of that. Sam?
I guess kind of like safety, but not instead of the consumer who's looking at it to protect themselves, it's maybe to like protect their company because they don't want to get sued for, putting in dangerous stuff.
Exactly. Protection of the following regulations, basically making sure that they're following regulation and they don't get in trouble. What else? We talked about, no, you're not Jacob, are you? Okay, you are Jacob. You have more efficient processes, so changing cooker, the example that we gave, how that would impact food quality.
Consistency between batches to make sure that your process isn't inconsistent when you're doing it.
Exactly, making sure that the process is consistent. Do we know the name? Jillian. Okay. Myson knows you, right? Yeah, got her. Yeah, anything else? We talked about something called forensics, right? So if you have a customer and they complain, they found a foreign matter, so you go through forensics to kind of identify the foreign matter. Okay, good. I think we kind of covered it all. So moving on, we have the government regulations. So we analyze food to follow government rules and regulations and international standards and policies. So nutrition labeling is kind of governed by government regulations. And we'll talk about nutrition label in a little bit here, more detail. You will learn about this, if you haven't already, in food quality, the good manufacturing practice, which is part of the HACCP. So basically manufacturing food to ensure its safety for the consumer. So analyzing the safety of the food to ensure that they followed good manufacturing practices. You'll learn more about that in food quality. CFR, do you know what it stands for? Code, oh, go ahead. Code of Federal Regulation, which is basically you find all the federal regulations in there. And most specifically, nutrition label, the tests or the methods that are to be used for certain composition on the nutrition label. So governing all the rules related to labeling, health claims, tests, you'll find that there. Standard of identity. Have you heard of that term, standard of identity? I'm hoping so. So every, like, a lot of products have standard of identity. Milk, for example, has standard of identity in terms of, let's say, composition, fat content. Well, that's what's the benefit of the project that you guys are not going to do, is knowing what standard of identity is and defining that. So Codex is also, it regulates the international trade, so ensuring a safe trade for the consumer, whether incoming or outgoing foods and ingredients. Okay, so again, this is something that students would deal with in, this is basically the project the student did in the past. They looked at analysis, different analytical methods that would manage product quality all the way from ingredients to processing, through processing and the final product. So the project used to be, we'll see if I bring it back next year. The project used to be that you would select a product and you would know what the ingredients are, and then you would determine what tests are done on the ingredients, and then what tests are done during processing, and what tests are done for the final product. So this way you're ensuring quality all the way from ingredients to final product. You don't necessarily prepare the product, you just write about the different tests that you would do to ensure product quality. So speaking of that, I thought about doing something different this year. Since you don't have a project, I'm just going to have a homework assignment. Not too complicated, a very simple homework assignment. I just felt bad that you guys are not going to get the benefit of people that got it last year. But it's going to be much less work. Nothing compared to what the students did. I can't find my cursor. Okay, there it is. Under week 1, I put here example of a project that was submitted by a student. I have very good examples, tons of them. I just picked one. What I will formulate a homework around this project. So navigate through the project to see the amount of work that students did, and now you're relieved from doing. But I will form about 10 points worth of a homework somewhere mid the semester, maybe the second half of the semester, so that you've learned a lot of the analytical methods, and then I will formulate a homework around that. So it won't be tedious, it's just I want you to get some of that experience that students have gotten in the past with much less work. Okay. So for ingredients that come in, sometimes they come in with specifications, or you as a producer, you have certain specification that you ask for. Let's say you are producing bread, loaf bread, you need certain type of flour. Not any flour. You don't want the soft wheat flour, you want the hard red wheat flour to do your loaf bread. So that has higher protein content. So that would be a specification that you would request. A certain amount of protein in your flour, and it has a certain premium. So it costs more than soft flour. So you have certain specifications for your ingredients. You build kind of a trust relationship with select suppliers. That means you always get from the same supplier, so you don't always have to check and test the ingredients as they come in, because you kind of have a trust relationship over years or whatever. Often each ingredient comes with a certificate of analysis. So they certify that the flour has 14% protein, has 2% ash, has certain amount of vitamins and minerals and fiber and what have you. So the ingredient supplier has done several analyses, and then they will give you a certificate. So you don't have to go ahead and analyze what they have analyzed already. But sometimes you want to make sure to do some in-house testing. Let's say you're getting milk. You want to make sure that it's safe from a microbiological standpoint during transport, that it didn't get any contamination. No antibiotics, for example, in your milk. So you might choose to do certain testing in-house to ensure safety and quality of the ingredient before you start processing. So every ingredient is unique. Let's say you're getting soy flour. Soy flour, you want to test for trypsin inhibitor. That's a very unique component in soy, because trypsin inhibitor will inhibit trypsin in our gut, digestive gut, and will inhibit protein digestion. So basically, you don't want to have trypsin inhibitor at greater than 10% of its activity in the soy flour. So that's something you would test. So every ingredient is unique, so you would select what you would test for different ingredients. During processing, so let's say you are making yogurt. You want to maintain a certain pH during the processing, a certain acidity, fat content, especially let's say you are producing low-fat yogurt. You want to make sure that the processing steps did not impact the fat content, the moisture content, total solids. So there are certain things you want to monitor at each processing step. And in order to ensure that the samples are the way they should be, usually you will have control samples that you would compare against. Final product. So when you get the final product, there's a whole lot of tests that you want to do. First of all, you want to make sure that you have the tests needed for the label, for the nutrition label. You want to make sure that your quality is consistent. Oftentimes, you do sensory evaluations to determine if it's acceptable. You want to make sure you make the tests that are required for health claims. Are you claiming high calcium? So you're putting calcium and osteoporosis claim. So you want to make sure you have that right amount of calcium for that claim. So basically, a whole lot of tests that can be done on the final product depending on what health claims you're making, what's the quality you're looking for, what's the acceptability of the consumers, etc. Okay, so now that we know that we have to do testing for different reasons and purposes, but if you were a food analyst that working in an industry, you need to know certain things. So you need to know what type of analysis you want to do. So basically, what am I analyzing? Am I analyzing composition of the sample? Do I want to analyze shelf life? What do I need to do? So first you need to figure out what type of analysis you need to perform. And then things begin to become complicated. Methods. For every type of analysis you learn throughout the semester, there's a ton of different methods that you can use. Sam? Okay. So there are different types of methods, so you would want to select methods based on the purpose, based on so many different choices that you have. We'll talk about examples in a minute. After you choose a method, you want to select a sample. So basically, if you have 100 tons of a sample that is being produced, you're not going to measure all of the amount of samples. So you have to make sure that you take a representative sample to run your analysis on. And that's a whole chapter. That's chapter 5. We're going to talk about that next week. And then how to prepare the sample to prevent bias and errors. So we chose the method, we selected the samples, now we run the different analytical techniques. And that's what we're going to learn all semester, all the different analytical techniques. So all the book basically talks about different analytical techniques. We'll learn about that. And then this is chapter 4. Once you obtain the data, what do you do with it? How do you analyze the data and how you interpret your data? So we'll talk about that next week as well. And then based on your data and interpretation, you make a decision. Accept a product, reject a product, determine the shelf life of your product. So basically, your data will end up helping you make a decision about it. While doing all of that, you keep government regulations in mind. So when we talk about nutrition labeling, for example, and the different types of methods, so the government really dictates what standard methods you would use for different types of analyses. So we really need to keep that in mind. Even there is regulation about how you do sampling and how you do sample preparation. So we need to keep that in mind. Also, there is regulations about detection limit, how sensitive the method needs to be, because there are like limit action or defect action level that you need to keep in mind when you choose a method. You need to know how sensitive it is based on what's allowed to be in the sample from a regulatory point of view. Okay, time for a question. So let's talk a little bit about type of analysis. So if we want to determine the type of analysis to be carried out, how do we determine that? Based on the type of product, the health claim, or the purpose? Come on.
The type of the product and the purpose.
Say your name first. Fam. A and C? Okay.
I think that's like all of the above. Because you're making certain health claims, you're going to want to test for those too.
Do you know who this gentleman is?
It's me.
Okay. Yes, it's all of the above really. A and C is correct, but also health claims. So if you're making a health claim that it is low in saturated fat or no trans fat, or you're making a claim of calcium or high protein or dietary fiber claim, so you really need to account for that analysis for that particular claim. Type of product. So is it a product high in fat? If it's a product high in fat, I want to ensure quality. Something I need to consider is rancidity. So I might be looking at oxidative or hydrolytic rancidity. Purpose. Is this analysis for quality or is it for nutrition label? If it's for nutrition label, then I have a whole lot of things I need to analyze. If it's for quality, it might be just moisture content or water activity or texture or sensory evaluation. So basically all of this play a role in deciding what type of analysis you're going to do. And I know this probably is a lot of information, but as we go through the semester, I'll be giving you and reminding you of examples of what I'm talking about now. Okay. So now we know what we want to analyze, then we have to choose a method. The choice of the method, really, first of all, you look at the characteristics of the method. And what do I mean by characteristic of the methods? For example, we talk about inherent properties. Do you know what we mean by specificity of the method? When you hear the term specificity, do you know what we mean by that? Tim?
If you're like testing for a most, I guess you can really use the word like specific, or I don't know, like a specific quality of the product maybe. So like if you're testing to like the fat content or something, you're not gonna like use a test that's looking for other things. It's gonna be specific to that.
you're right. I'm going to give an example of what you really wanted to say in terms of specificity. You're looking for something specific. For example, determining total carbohydrate versus determining glucose content. Okay? So if I really want to know the amount of glucose I have in my sample, I would have to choose a method specific for glucose. It won't detect fructose, it won't detect lactose, it won't detect sucrose. So I really want glucose. Or if I want total sugar, then it would be a method that is non-specific for glucose, but specific for sugar. Or I want a reducing, and the amount of reducing sugar. So it would detect the reducing sugars and it would not detect sucrose. So it really depends on what you want to do. Then you would have to select a method that is specific enough for what you want to analyze. Okay, do you know the difference between precision and accuracy? I'm sure you've heard about that since high school, but it's going to come a lot during this semester. You're always going to be assessing your, especially in the lab, your precision and accuracy. So do you know what the difference is? Yeah, let's see. Let's go with Nico.
So precision is when you compare your results to each other, while accuracy is comparing your results to an accepted value.
Exactly. So precision is how precise you were in your analysis. So oftentimes when you do an experiment, you have replication. You never do the experiment once. You replicate. And when you replicate, you calculate standard deviation and you calculate coefficient of variation. And we're going to talk about that next week in the data analysis section.
Nico.
So for precision, so how close your replication was. Do you have a 10% coefficient of variation or higher? That means your precision was not that great. It might not be your fault. It might be the method's fault. There are so many steps, so many rooms for error, so you don't get good precision from your method. Accuracy is, sometimes I'll tell you when you're doing a lab on composition, I'll tell you, okay, this is the protein content of cheddar cheese. Go look up on the USDA the protein content of cheddar cheese and compare your value to that value. So how accurate your result was compared to the reported value of that product. So we will calculate percent relative error, and then we'll talk about that next week. So these are the inherent properties of the method, but also specificity is inherent to the method, but precision and accuracy is not only inherent to the method. It also depends on the experimenter, that you're running the experiment. And we'll talk about that later. Applicability of the method. How much do you have the reagents? Do you have the equipment? How expensive are the reagents? What sample size does it require? Sometimes you get a gram of sample and nothing more than that, but the method calls for 2 grams of samples. You can't afford that. You cannot run that method. So sample size is really important, and whether or not you have the reagents and equipment to allow you to run that method. Is it a method that is lengthy and simply you don't have time for it? How reliable? That really depends on the precision and accuracy. And do we really need to run this analysis? Safety is a big thing. So let's say you're running ash. We'll learn about running ash by acid digestion versus running ash using a muffle furnace. Determining the mineral content using acid analysis is really not very safe method. So do we really need to, then you have to determine, do I really need to run the method using acid digestion, or can I just do ash by dry ashing? So how safe are the procedure? Do you have the right training? Do you have the right hood? Sometimes you need a specific hood, like perchloric acid hood for that acid digestion. So that is something also to consider. Okay, once you consider the inherent properties of the method and the characteristic of the method, then you want to determine what's the objective of the method. What I mean by that, do you want to determine nutrition labeling? That requires an official method of analysis. Official method of analysis, I'll give you examples at the end. It means a method that has been validated by an official entity. So it has been tested and it was made official by validating it, and it's also called primary, definitive, or reference. All mean the same thing. And you are bound to use official method of analysis when you are determining nutritional labeling. Rapid quality control, that means you probably heard of NIR, near infrared spectroscopy. You use near IR to determine composition very quickly. You put the samples in powder form, if it is a powder, or liquid form, and you just put it in the machine and the machine spits out the composition very easily. We're going to talk about that in spectroscopy later on in the semester. So it's a rapid method just to determine quality. I used to work at a flour mill, and my job, part of my job, is to determine the quality of the flour as it comes out from the mill. So we had NIR, we just have, okay, this is the amount of ash. If it has too high of an ash, I go tell the miller there's something off, there's contamination, there's something off going on. So quick and rapid quality control. We call them secondary methods because they are calibrated by the primary methods. So the NIR that you would use, it has to be calibrated by an official method. You're determining the fat content by NIR, you have to have that machine calibrated by values obtained from Mujiner, for example, or from Soxhlet method. And these are methods we're going to talk about later in the semester. So that's why this is called primary and this is called secondary, because it is calibrated using the primary method. Online measurements, oftentimes you just want a quick measure of moisture during processing or quick measure of protein during processing. So again, it's similar to rapid quality control, the same thing, it's also secondary methods of analysis. You wouldn't go and do moisture using oven, which takes an overnight time to determine the moisture content. You would use infrared instrument to measure that, or a microwave oven, which you'll learn about in lab as well. Okay. Also, the choice of the method and how you analyze really depends on the composition. Is it high fat, high carbohydrate, or high fat, high protein, or is it all carbohydrate, all protein, or all fat, or mostly fat? So it really depends on the composition. And here's an example. Let's talk a little bit about an example of the composition. So you want to determine fat content in a food product. And that food product happens to be high in carbohydrate and protein. The sample preparation should include which of the following you think? Logic. It's okay if you guess wrong, but if you guess, be prepared to say something. Now nobody's going to say anything. Oh, come on. Yeah, go ahead, say your name first. No, not you. Sorry. I know that you're Alex. Sorry. I didn't see your hand up, Alex. But go ahead. You're Devin, right? Solvent extraction. Alex, what were you going to say? Why would you say that?
Well, you want fat, and there's lots of other things that get the plant into extracting all the fat. So acid hydrolysis would break some of that stuff down.
That is correct. Have you done vagina in our lab, Alex? Okay, but that's correct. Good that you remembered that. Okay, so Yes, basically fat and protein and carbohydrate are present in a complex matrix in food. So they're interacting with each other. So if you go ahead and you want to extract the fat and determine the content of the fat using solvent extraction, the solvent might not be able to extract all the fat that is entangled with the protein and carbohydrate in a complex matrix. So you want to break it up. Oftentimes you do pre-drying. I didn't state the moisture content here, but if the moisture is high, often, and depending on the method, some methods require to pre-dry, other methods does not require you to pre-dry. Again, in that fat analysis lecture, I'll talk about that more in depth. But let's take away pre-drying and focus on acid hydrolysis. Here's an example that looked at acid hydrolysis by determining fat with no acid hydrolysis. So let's take one that is called, let's say, take the dried eggs. Without acid hydrolysis, you have about 37% fat. If you hydrolyze, then you're getting about 42% fat. So you got back 5% of fat that you were not able to determine without hydrolyzing. So eggs are high in protein, so basically your fat is entangled in the protein. So hydrolyzing will break that protein matrix and allow the solvent to extract the fat. So in lab, you will be learning two different methods that require two different procedures and different sample preparation. And you'll be able to compare your fat content using different methods and having different samples to start with. So validity of the method is another consideration. So the validity is you validate based on the characteristic of the methods that we talked about. Precision and variability are really similar. If you run the method today and you run it tomorrow, are you going to get the same results or similar results? How variable is your data? How variable your data is, and how repeatable the results. So basically, this is related. So everything we talked about, characteristics of the method, and to validate the method, you can sometimes measure standards. So you can obtain standard references. This is short for National Institute of Standards and Technology. So they offer standards where you can get those standards and the values associated with these standards, and you run your methods and see if you get similar results to what is said or what came with that standard. So that way you validate your method. Another way to validate your method is to get check sample services. So American Association of Serial Chemists, now it's international, it has an I next to it, and American Oil Chemist Society, they offer check sample services. What does that mean? This means that they send you samples, standards, and you run them using your method and another standard method. And you send them the data. And then they will analyze and give you a report and tell you the validity of your new method compared to a standard method. Other times you have internal control samples that you keep for analyzing all the time. So if your method is changed, you get your control samples, you run the analysis and determine if you get similar results. And that's a way to validate that method. So remember this, when I ask in a quiz, how would you validate a method, remember what we just talked about. Okay. So here are a few examples of official methods that are published by different organizations. These organizations have validated the method, tested them in different labs, and finalized them and made those methods official because they are published in by official organization. This is, its official name is Association of Official Agricultural Chemists. It's also known as Association of Official Analytical Chemists, but it's not the official name. But it's known both ways, and they have their own official methods of analysis, and you can see this is just an example of what methods are there. Often for projects, students go to that website. We have it accessed through the library and look up methods or official methods of analysis there. So it is a very valuable tool. If you're not going to use it for project, you're probably going to use it for your capstone. So it's good to navigate and look up methods that way. Another organization is the American Association of Serial Chemists, and now it has international due to its international aspect. So it has an I. It used not to have an I. Now it has an I. And it's basically for cereal products, flour and other cereal from wheat and other cereals. And there are those all different types of analyses or methods that are used for cereal specifically. This is American Oil Chemist Society. This is especially for oil and oil seeds products. So again, there are a number of methods specific for these types of ingredients and products. And another one is common for dairy and American Public Health Association standard methods for the examination of dairy products. This is also the go-to methods for dairy. These, again, for projects, we use them a lot depending on the products. And that's it for this intro. I'm just going to start the next one, which is nutrition labeling related to your lab next week. We will not finish it today, but at least we'll get it started. All right. What does FDA stand for? Yep, and what does FSIS stand for? No? No, not in food quality? It's not covered in food quality? All right, say your name first, please.
Daniel. I'm not 100% sure, but I think it's like food safety and inspection services.
Yes, thank you very much. Food safety and inspection services. They put together regulations for labeling, and based on this regulation, let's see which of these statements is true, or which of these statements are true. Okay. Zach.
My first guess would be C, the bottom of every nutrition label I've seen, there's always been percentage of
Let's hold that thought. Any other true statements? No? Sam?
I would say E as well because I think vitamin A. Never mind. I something else.
Retracted. Anything else? Nothing's jumping at you? I'll wait. Okay. What? Were you going to say something? Okay, none of them is correct. Usually I have several that says A, B, C, all of them, but none of them is correct. This used to be in 1973. That was the nutrition label is only required if the food had an added nutrient. Yeah, A and B was actually in 1973. The amendment made later, 1991, made it, or 1990, made it required for all food. This one, showing percent for daily value of protein, is not mandatory unless it is for athlete or there is a protein claim, or if it is for children under 4 years of age. So it's not mandatory for every product. Methods of analysis are to be determined not by the manufacturer, by the regulatory agency, either FDA or USDA. Stating percent daily value of vitamin A currently, the new one is not going to have even vitamin A on it, and definitely not vitamin B12. Okay, so a little bit of a history. So the Food and Drug Administration, FDA, regulates nutrition labeling for almost, yes, Ted?
On the protein thing from the last one, is that changing the new labeling?
No, it's staying the same. I'll show you the new label in a minute. So, yeah, so I was saying the FDA regulates the nutrition label of all food with the exception of meat, poultry, and egg that is regulated by the FSIS of the USDA. So it started in 1906, the FDA Act and the Food and Drug and Cosmetic Acts of 1938. It's when they started saying, okay, we need to have something on the label. And it started to be the amount of food in the package, the common name, and the ingredients. And then there was another regulation that came out in 1973, and they required a little bit more on the label, macronutrients information and some minerals and vitamins. And then the 1990 Nutrition Labeling and Education Act now it became mandatory. It's not optional, and it has nutrient content and nutritional value, and I'll show you in a minute. So yeah, it used to be optional in 1973 unless there is a nutrient claim, over there or added nutrient. Like if you added a fortified with iron, for example, you have to put that on the label. So in 1990, it became almost all food with few exceptions. Do you know which type of foods do not require nutrition label? Yes, Zach. I think there is on the beer, doesn't it? No. Okay, I don't drink beer, so I don't know. Okay, Caitlin?
I was going to say the supplements.
Supplements, yep. And there are others. Like if you have small packs, packed into a bigger pack, so you won't find nutritional label on the smaller packs. You'll find it on the container. And I think like produce won't have, obviously, and eggs won't have. So there are some foods that won't have nutrition label. So from 1973, the reason it changed in 1990, around that era, people were more concerned with macronutrients like fat content and calories. So they're not so much concerned with the micronutrients and the components of the macronutrients like saturated fat, amount of sodium, and the impact on hypertension, dietary fiber, and impact on colon cancer. So when people around this time started thinking about beyond macronutrients, we started seeing the nutrition labeling became mandatory and had components like saturated fat, cholesterol, sodium, and other components on the nutrition label. So these are the current components of a nutrition label, but I want to point out that trans fat was not mandated in 1990. It came in 2003 as an amendment. So in 2003, trans fat was added to the nutrition label. Now, there has been a new proposed nutrition label that differ in few things. So it was proposed in 2014, approved in 2016, yet the compliance date is 2020 for large companies that sell about over $10 million per year in sales, or 2021 for companies that are smaller. So they gave them a little bit more time. We have visitors from General Mills. I will wrap up in 30 seconds. I'm going to stop here, but I just want to show you what we're doing in the lab. I didn't pay attention to time. Okay, so you guys are going to do nutrition labeling using Tech Wizard program. You're going to generate a nutrition label for a yogurt formula, and we're going to change formulation, and you're going to see how the change in formulation will impact nutrition labeling. You're going to observe an example reverse engineering, and you're going to make a nutrition label for a chocolate chip cookie. This is really a good exercise to learn and keep with you for capstone. You're going to be using it in capstone. So that's what we're going to do. Please read chapter 3 in the book because I haven't gone through the material yet. And also chapter 5, you need your lab manual next week in lab. Please bring it and review chapter 5. There is already on Canvas the pre-lab quiz. Well, it's on Canvas. Sorry, I updated this but did not update that. And hand to your TA in the morning. We are meeting in ABLMS 135. I'll give you some intro and then we all walk to the computer lab. So meeting point is ABLMS. Bring your lab notebook please with you. And lab handouts, actually we're going to give you some lab handouts. Cindy's going to make copies for you. Please come on time. There's a lot to cover next week. So lab starts at 9:30. Please come at 9:25 so we get settled. Thank you, and I'm going to hand it over to two wonderful former students.
Hi, Kirsten. Hi, I'm Lauren. I'm Kirsten. We were originally in food analysis with Pam a long time ago and graduate students with her, but we currently work at General Mills and just wanted to remind everybody that we have an info session next week, Tuesday, 4:30 to 5:30.
And so it starts off with 15 minutes before that, Science Nutrition Club. We're going to start off with 15 minutes and hand it over to General Mills. So you guys show up.
Yes, I'll be looking, like, kind of giving more information about recruiting for internships, which we have some
Yeah, we have
snacks
some
and
handouts
handouts.
and snacks, all like
So-
pick up by the back if you want to grab it. It's great to learn about, even if you don't think you want to do an internship or something right away. It's always good just to learn more about the company. There'll be free food, the Science Nutrition Club, so really good way to learn more.
Yeah, so
Hope everybody can come.
Great.
Any questions now, you can also chat with us in your class time.
Both, well, actually Lauren did an internship with General Mills and got hired after that, right?
yes.
Yeah, so doing an internship is really great and it's like one foot in the door. Kirsten is an anomaly. She got hired without an internship.
Yes, there is sometimes those openings too. So there have been other students who came after me who also got hired in full time. So even if you're not planning necessarily to do grad school, there's other ways in too. So we'll be talking more, I think, a little bit about the presentation, some of the other routes beyond just the on-campus hiring process.
Cool. You guys are off.